So we're looking at an equation of a circle that's in general form. We want to put it in standard form so that we could tell what the radius in the circle is. Radius of the circle and the center of the circle. So standard form is x minus h quantity squared plus y minus k quantity squared is equal to r squared. So I notice my x terms is written as a perfect square and my y terms are written as a perfect square, my constants on the other side. So for these types of equations, to put it into the standard form, we want to group our x terms together, we want to group our y terms together, get the constant on the other side. So I'm just going to rewrite my equation, x squared, and carry the sign in front of the term, so minus 2x. I technically really want to add something here to make this a perfect square. So I'm just going to leave some room in here so I can come back and figure out what I need to add to make that a perfect square. So let's group our y terms together. So I'm going to rewrite this as plus y squared minus 8y. And then again, I know I'm going to want to come back in here, add some constant in here to make this a perfect square for my y terms. We want the constant on the other side. And so I can move that negative 19 on the left-hand side to the right-hand side by adding 19 to both sides of my equation. So adding 19 is going to cancel the negative 19 on the left and give me a 19 on the right. The thing is, if I add something to one side of the equation, I have to add it to the other side of the equation to remain equal. So we're going to add something to the x terms. I need to add that to the other side. I'm going to add something to my y terms, so I also need to add that to the other side. Okay, so remember, completing the square, that coefficient in front of the square term has to be 1, which it is. So we're good. If it's not 1 in your example, then divide every term by that would make it a 1. So remember, a perfect square, you're looking at your value in front of the x. We want the same number that would add to give us that value. So I'm thinking to myself, what can I add to itself to get back negative 2? Well, I can add negative 1, because negative 1 plus negative 1 is negative 2. So that number that I added to itself, I want to square it. So negative 1 quantity squared, that gives me 1. So I want to add 1 to that. And by doing so, this is a perfect square. So it would be x, in this case, minus 1. Because negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 is negative 2. So I want to do the same thing with my y terms. So I'm looking at what is the same number now, though, that adds to itself, we get negative 8. Well, to find that number, you can always half it. Sometimes they're not as easy as this. Well, negative 8 divided by 2 is negative 4. And I know negative 4 plus negative 4 is negative 8. So I take that negative 4, that number I add to itself, and I square it. So negative 4 quantity squared gives me 16. So I need to add 16 to both sides of this equation. But the whole point of completing the square, adding that number so we can make this a perfect square. So it's going to be y, what number are you doing? Multiplying to get 16, adding to get negative 8 is negative 4. So I can rewrite this as y minus 4 quantity squared. This is equal to, well, let's sum 19 plus 1 plus 16. 19 plus 1 is 20. 20 plus 16 is 36. So now I've written it in standard form. And so my centering here is always the opposite sign. So this is x minus h. So my center is the h value. So my center, opposite sign of negative 1 is 1. So that's the x value of my center. Opposite sign of negative 4 is positive 4. So I can see my center is at 1, 4. My radius is equal to the square root of what it was equal to. So r is equal to the square root of 36. So R is 6. So we found the center, we found the radius. Now we can easily graph this by first plotting the center, which is to the right 1, up 4. I know from my center, I can get points on my circle by going up, down, left, and right, my radius. And so my radius is 6. So if I go up 6 from 4, I have a point here at 110. If I go down 6 from 4, I'll be at -2. If I go to the right 6 when x is 1, I will now have a point at 7, or yeah, 7, 4. And I'm going to go to the left. That was the right. Going to the left, 6. So 1 minus 6, I know, is -5. So now graphing this, X. That does not look like a circle. I know what I did wrong. I don't know why I put it on the x-axis, but that was at, this looks better, -5, 4. It's hard to make circles, but that looks correct. And from making the graph, I can also tell how many intercepts I'm going to have. I know it looks like I'm crossing my y-axis twice, and I'm crossing my x-axis twice. To find our intercepts, we can either go back to our original equation, or it's actually easier to go back to the one that you had just found in standard form. If we do this, then we can use that square root method we had learned at the beginning of the semester. So to find the x-intercept, recall wherever we're crossing the x-axis, y is 0, so we're going to let y equals 0. So I'm just going to go back into that equation and plug in 0 for y and solve for x. So I would have x minus 1 quantity squared plus, letting y equal 0, so 0 minus 4 quantity squared is equal to 36. So let's isolate the quantity square. So I have x minus 1 quantity squared plus, well, -4 quantity squared, -4 times -4 is 16, equals 36. Let's, again, isolate that square. So let's subtract 16 on both sides of our equation to get that perfect square by itself. 36 minus the 16 gives us 20. Now I can use my square root method. I can get rid of that square by taking the square root of both sides. Don't forget that plus or minus in front. And so if I take a square root of the square, I'm left with x minus 1 plus or minus square root of 20. I know 20 has a factor that's a perfect square. 4 times 5 is 20. So I can look at the square root of 4, which is 2, and that 5 is still left under the radical. So to get the exact answer of where it's crossing the x-axis, I would add 1 to both sides. So you get 1 plus or minus 2 root 5. If they want you to estimate it, then go back in and plug that into the calculator. 1 plus 2 root 5 and 1 minus 2 root 5. So that's the x-intercept. Y-intercept, almost the exact same thing, except we know when we're crossing the y-axis, x is always 0. So we're going to let x equal 0. So instead, we're going into that equation that we found in standard form. plugging in 0 for x and solving for y. So I get 0 minus 1 quantity squared plus y minus 4 quantity squared equals 36. Squaring -1 times -1 is 1, plus y minus 4 quantity squared equals 36. Subtract 1, so I have y minus 4 quantity squared equals 35. Takes the square root of both sides, plus or minus in front of one of the sides. So taking the square root of the square leaves me what I was squaring. So I have y minus 4 equals plus or minus. There's no factor of 35. That's a perfect square. So I'm going to just rewrite it as 35 under the radical. Add 4 to both sides. We get y equals 4 plus or minus root 35. So we were able to put it in standard form, find the center and the radius once it's in that form. We were able to graph it by plotting the center, going up, down, left, right, the radius from the center, and then found the intercepts by either letting x equal to 0, solving for y, or letting y equal to 0 and solving for x.